Ciao friends and welcome to a new video from SQL BI. In this video, I want to talk about data types, performance and precision of calculations. I often teach during my trainings that when in import mode, Power BI is data type independent. It does not really matter whether you store a date, a string, a floating point. All these data types will be converted in a way that makes the storage and the speed of scanning those columns basically the same no matter what the data type is. However, when you store numbers, it is important to choose the correct data type and to pay attention to small details, because using the wrong data type or a date or writing the DAX code in a way that is not optimal, you can easily create issues from the performance point of view. Besides, when it comes to precision, whenever you store a number in a computer, not only in Power BI, there is always some sort of rounding, because you can store a floating point, and the floating point has 15 digits of decimal places that you can use. If the numbers you want to store has more digits, they will be truncated or rounded. This introduces errors everywhere. But the thing is, these errors are so small that nobody cares about them, because you will never see the error. However, when a tiny error is multiplied by a lot of rows, then the error becomes evident, and you need to pay attention to this in order to produce coherent values. However, I don't want to spend time describing everything in the introduction. Let's go to the demo and let's see how the data type affects performance and precision of calculations. I'm using our usual Contoso data model, and the topic is currency exchange. So we have sales, we have data, and currency, because sales happen with a specific currency. However, despite the currency we are using for the transaction, all the values in sales are stored as dollar values. So if you look at sales, we have unit price, net price, unit cost. These values are always in US dollars. And I need that because I want to sum the values, compare the values, so I need only one currency to store the value. However, I also keep track of the original currency that was used in order to perform the transaction. So I store dollars, but I remember the currency that was used. And if at some point I want to produce a report that shows the amounts in the original currency, I need to perform currency conversion. And I need to do that transaction by transaction, because every day the conversion rate is different. That is why I have stored still in the sales table also the exchange rate. This is telling me that the exchange rate and that specific date between dollars and pounds was the given number. I use this column in order to perform the multiplication. So if I want to produce the sales amount in the original currency, it is enough to compute quantity times net price times the exchange rate. I'm going to test that with a query. So I create a measure, sales original amount, where I iterate over sales, and for each row in sales, I compute the exchange rate times the quantity times the net price. Let's take a look at the data types of the three columns that I'm using. Quantity is an integer. Whenever you want to look at the data type, you need to look at this section. This is telling me that it is a whole number and it is formatted as a whole number. Remember, format strings are a thing, how you see data. The data type is how you store data. So for the quantity, it's pretty easy. For the net price is a fixed decimal number that is a currency as it is stored, and then I'm showing it as a decimal number, but the way I'm storing it is a fixed decimal number, that is a currency. Whereas the exchange rate, well, for the exchange rate I need more precision. So I'm not using a fixed decimal number, I'm using a decimal number, because that gives me more digits after the dot, so that I can do math in a more precise way, and I still show it as a decimal number. So this means that I have my three columns in my model, and I'm multiplying a floating point exchange rate by quantity that is an integer times the net price, which is a currency. I'm using 3 different data types in the same expression. Now, when it comes to data type conversion or performing math on mixed data types, the engine needs to be extremely careful because, as I said, whenever you store a number in a computer, there is always some sort of rounding. But you need to make sure, if you build a tool like Power BI, that the rounding happens always in the same way and there are no small errors that might propagate when multiplied by a large number of rows. That is the reason why the conversion and the multiplication specifically between floating point and currency cannot be executed by the storage engine. The storage engine can only perform math on simpler data types. But when you mix floating point and currencies, then you need to invoke the formula engine. This means that as innocent as this query looks like, doing the 3 multiplication and then grouping by currency code and showing the original amount and the USD amount, requires us to invoke the formula engine to perform the multiplication. Let me enable server timings. Then we run the code. It's going to be pretty fast. And we have the result that shows the original currency, the original amount, that is the amount expressed with the original currency, and the USD amount, which is nothing but the sales amount. The numbers are correct, but if we take a look at the server timings, you see that the query was pretty fast. It ran in half a second. But if we look at the storage engine CPU, it took 3.6 seconds of storage engine CPU, with a degree of parallelism of 9.0, meaning that the query has been executed in half a second, but not because the algorithm is pretty good. The thing is, the massive parallelism speed up the query by a lot. However, there is a value for the storage engine that is definitely too large. And there are 2 storage engine queries. If we look at the first one, you see that we have expression 1 that executes a round value callback in order to make this calculation, that is the multiplication that I'm performing, and ask being executed by the formula engine. So the storage engine asks to the formula engine to perform the calculation row by row. And because I'm using a data model that contains 200 million rows in the sales table, this communication between the formula engine and the storage engine is happening 200 million times. That is why I have this large amount for the storage engine CPU. In order to make the query faster, what I need to do is get rid of this conversion. And the conversion, remember, happens because I'm using a decimal multiplied by a fixed decimal, a floating point multiplied by a currency. So how can I overcome this limitation and avoid the callback? One idea might be that of changing the data type of exchange rate. Why am I using a floating point? I could use a currency also there, and that will solve the problem because no conversion needs to happen. And the multiplication of 2 currencies can be executed by the storage engine. However, by doing that, I'm introducing further roundings. And a tiny rounding happening at the leaf level, so the transaction level, multiplied by 200 million rows, might produce a different result. We can evaluate that, not the speed but the precision, by simply using currency here. So we change that to a currency. And probably the best thing that we can do is let's copy everything. Let's do that in a new window. And we execute it here. I'm converting the exchange rate to a currency and I'm computing here the original amount. Now, if you look at this number, let's look at the last digit, 583.74, and we look at the number here, you see that they are different, 591.55. So the value for Australian dollar, Canadian dollars, euro and Great Britain pounds is quite always different. And it is different because of the rounding. Reducing the number of digits of the exchange rate changes the algorithm. In this specific case, this number is actually more correct than the previous one, but that is just because of this specific example. In general, Doing the conversion at the transaction level, so row by row, introduces a tiny error that multiplied by 200 million rows generates a difference. And this, of course, is a serious issue, because you produce numbers which are no longer correct. However, whether this value is correct, the one computed with using the currency, or this value is correct, is quite debatable, because remember that rounding happens everywhere. And rounding actually happened when we decided to store US dollars and the value was in Canadian dollars or in British pound. Doing the conversion, there was already a rounding, and that rounding multiplied by all the rows might produce a gigantic error. The key to produce correct numbers or more correct numbers and to avoid the problem in terms of performance is that of reducing to a minimum the number of multiplication, aggregate values as much as we can before performing the multiplication. In this case, if we go back to our original query, what we can do is avoid iterating over sales. Instead of iterating over sales, because the problem is introduced by this multiplication, let's get rid of currency in the meantime. This is the multiplication that creates us problem. Exchange rate times quantity times net price. So I want to get rid of this multiplication and move it at a different level. In order to do that, I can iterate not over sales, but over values of sales exchange rate. So I iterate not the entire sales table, 200 million rows, but only the exchange rate values. And then I compute the exchange rate times, I can no longer use quantity times net price, but I can use sales amount. Rely on the context transition and compute the sales amount, that is only computing quantity times net price, sum all these values together and multiply by the value of sales exchange rate. This moves the multiplication to the formula engine, and I would expect the storage engine to compute the sales amount grouped by values of exchange rate and this final multiplication being executed by the formula engine. If we take a look at the server timings again, please take a look at the values, the number of rows which are being returned by the two queries. It's 8 rows here, and this is a tiny query that only retrieves the currency code, so we are not interested in that. But I'm retrieving 8 rows, and I'm taking 3.5 seconds to do that. If I change the code of sales amount of original amount by iterating sales exchange rate and I execute the code, the numbers will be different. The most important thing is that now the storage engine CPU went down to 600 milliseconds. It was more than 3 seconds, now it's around half a second. On the other hand, the number of rows is largely increased, because now the query is grouping by exchange rate and currency code, and it's computing just the sales amount. And I have an additional query because the engine is no longer able to group the two subqueries together. However, it is faster. But the thing is the result more correct? Well, if I look at the result, you see that this number, well, we no longer have the original ones, so what we can do is add another measure. Let's add the original amount that just iterate over sales and compute exchange rate times sales and net sales quantity times sales and net price, and let's call it original amount 2, and this is 1 just because that was the first one we used, and then we use original amount 1 and original amount 2. One is the first one we wrote, and the second is the one that iterates over exchange rate. Execute the code, and now we have the two values. And you see that they are not the same. Original amount 1 is 501.55, this is 583.74. The difference is quite large. 044, 030, 307, 278. There is always a difference between the two values. Does this mean that this version is wrong and this version is correct? Actually, no. both values are somewhat wrong at the transaction level, because the original error was introduced when we converted Canadian dollars to USD. There was an error already there. If we convert it back, we will not get the very same result. There will be a tiny difference, but that tiny difference multiplied by 200 million rows produces a different result. However, performance-wise, if I get rid of performance-wise, we already analyzed. Original amount sales to does no longer require a callback. It just executes everything in the storage engine. So it is faster and it produces a different number. The interesting question is, well, it produces a different number, but at the same time, the number is wrong. Look, we think it is wrong because we have seen sales original amount 1 first and original amount 2 second. So we take for granted that the first number is correct and this one is wrong, just because we computed as the second option. But that is not true. As I said, both are somewhat wrong. You only need to make a decision about which level of wrongness you are likely to accept. And it turns out that original amount 2 is actually a bit less wrong than original amount 1, because original amount 1 performs this multiplication at the transaction level, so the error is introduced for each individual row, whereas original amount 2 performs the calculation and multiplies by exchange rate, where I might have the error, for a smaller number of rows. So it is still wrong, it's a bit less wrong. And if you are worried about numbers being correct or wrong, look at what happens if, for example, I use a different definition for original amount 2. Instead of using iterate over the net price, I just replace quantity, net price, and do the multiplication in a different way. I multiply by net price first and by quantity last next. And then I run the code. If you look at these numbers, they are still different. They are iterating over sales. This is performing the multiplication in one way. This other one is doing the multiplication in a slightly different way. And if you look at the numbers, they are still different. Not only this, if my model was a bit larger and I execute the code multiple times, I might obtain slightly different numbers every time I run them. Tiny errors multiplied by a large number of rows produce incorrect results. Not incorrect, rounded results. And that is normal. Be prepared for that. Whenever you work with computers, the dream of always obtaining the same number is nothing but a dream, because rounding happens everywhere. It happened at the very beginning when we store the data to begin with. And then we carry this error, we multiply by the number of rows, we multiply by the number of operations we perform. So choosing the data type is important. Writing the DAX code the right way is important, and writing the DAX code always in the same way, checking these details, is important. As you have seen, the different data types affect the way calculation happens. Now, if you have a data model that contains 1 million rows, that is not a big deal, because the number of operations that happen is quite small, and the error is really, really tiny. You will never notice that. But as soon as you have a larger model, or if you perform a lot of mathematical operations, then rounding always happens. And be prepared to have numbers that do not match. Do not take for granted that the first number you see is the correct one, and you need to compare everything with that number. That would be wrong. Think about your formula. Think about how numbers are stored in computers, where the rounding errors might appear, and then choose the version that is the less wrong one. And after that, pay attention to the order of the operation and the calculation that you perform in order to obtain coherent results. And if still there are tiny errors, be prepared to talk with users and explain them that yes, there is a tiny error, which is not an error. It's just a rounding that happens in different ways depending on how you write your code. Enjoy DAX!